we started off talking about kinematics, which is the movement of a body without reference to the forces moving it. We drilled down into osteokinematics, the movements of different bone surfaces and around joints. The joint is the axis. It's mostly rotational movement. We're going to drill down even a little farther to arthrokinematics. So arthrokinematics is the motion that occurs between the articular surfaces of the joint, so where the joints articulate. It's different from osteokinematics because osteokinematics is just talking about the path of the moving bone. The articular surfaces are kind of doing something different. So you can sort of think of it as the door opening is the osteokinematics, and what's happening in the hinge is the arthrokinematics. So the hinges are the joints, which makes sense, right? They are. So our learning objectives for this is we want to be able to describe 3 different arthrokinematic movements that happen between joint surfaces. And there are 2 rules governing arthrokinematics. Convex-concave rules is what we call them, and what their application is to normal joint surface movement. So in the text, for every joint we talk about, there's some very detailed arthrokinematics for each joint movement, and I am not going to expect you to know those as we go on through this course. The reason we want to know about arthrokinematics in the clinic is when we're doing joint mobilizations. Which direction do we need to move the bone in order to get the joint surface movement that we want? So right now we are planting the seed of arthrokinematic movements. Later on, the flower will bloom. So the flower is going to bloom in the lab when you're in your manual therapy lab when you're talking about joint mobilizations. So the seed has to have a long time to germinate. So we're planting it now, so then we have a flower later on. It's like planting bulbs in the fall, so you have flowers in the spring. If you don't plant the bulbs in the fall, your daffodils and tulips will never come up. So here we are, we're planting daffodils and tulips. So arthrokinematics is the motion between articular surfaces. So generally, the articular surfaces of joint are curves, with one surface being relatively concave and one being relatively convex. So the convex-concave relationship of joints, it improves joint congruency, which is fit, and it improves the stability of the joint. So it helps to guide the motion between the bones. That's the whole idea of why you have a convex surface and a concave surface coming together. You have good fit, good stability, and it guides the motion of the joints. So the fundamental movements of arthrokinematics are going to vary depending on whether a concave articular surface is moving on a fixed convex surface or vice versa. So we'll talk about that, how that happens. So the fundamental movement between joint surfaces, and there are 3 movements that can happen: roll, slide, and spin. So roll is where multiple points along a rotating articular surface contact multiple points on another articular surface. So the example, the world example, is the tire rotating across a stretch of pavement. So lots of points on the tire are contacting lots of points on the surface. Okay, so that's roll. Slide is where a single point on one articular surface contacts multiple points on another. That's like a stationary tire. You've locked your brakes and you're skidding across the ice. So that's slide. So roll, the tire's rolling. Slide, you're sliding. Hopefully that makes sense. And the third fundamental movement is spin, where a single point on one articular surface rotates on a single point on another articular surface. So the example is the rotating toy top spinning on one spot on the floor, or a ballerina on point spinning on one spot on the floor. That's spin. So Those are the three things that joint surfaces can do. And so why do we care, right? So we care because we want our movements to promote joint stability and joint congruity. Okay, so the arthrokinematic motions that occur between articular surfaces follow specific rules to promote that stability. So the first rule is the convex-on-concave. So you have a good example is the condyles of the femur rotating on the tibial plateau. The condyles of the femur are convex, the tibial plateau is concave. So if you have your foot planted and you're sitting down into a chair, so you're flexing your knee, and when the convex joint surfaces moves on the concave joint surface, roll and slide occur in the opposite direction. So as we go from, I should get a femur. Hey, there's a good idea. I just have to have one right here. So it's always nice to have a femur lying around. So as we go from, so we have our convex femur moving on our concave tibial plateau. As we go from standing, so we're standing, our foot is planted, we're gonna sit down in a chair. We're gonna flex our knee to sit in that chair. So as the first thing that happens is roll. So multiple surfaces on the femur start to contact multiple surfaces on the tibial plateau. Roll, roll, roll. Then, in order to maintain joint congruency, it has to slide in the opposite direction. So it's rolling in that direction, it's sliding in that direction. So you don't just roll right off your knee. Okay. Of course, the muscles and ligaments will have something to say about that. But so it has to roll in one direction and then slide in the opposite direction to maintain joint congruency. Okay, that's our first example. So I'm going to go over that again. So convex on concave, roll and slide occur in opposite directions. So it rolls one way, and just before it's about to roll off the edge, it slides back in the other direction. Okay. Concave on convex. When a concave joint surface moves on a stationary convex joint surface, the roll and slide occur in the same direction. So back to our knee. So now we were sitting in the chair for a while. It's time to get up again. And so I'm sorry, we're going to sit in the chair and we're going to extend our knee. We're going to do some quadriceps exercises, extending our knee. So now the concave tibial plateau is moving on the convex femur. So as you extend your knee, roll and slide happen in the same direction. So it's rolling that way and it's sliding that way. Okay, because if it rolled that way and then it slid the opposite direction, we're not maintaining congruency. The tibia is going to slide right off the femur. Okay, so we'll do that again. Concave moving on convex, roll and slide in the same direction. Convex moving on concave, roll and slide in the opposite direction. So Claudia came up with a nice little way to remember this, and her way for remembering the concave on convex, when you're in a cave, you want to stick together. So roll and slide happen in the same direction. And then the opposite. So that's Claudia's way for remembering it. You can come up with your own way, or you can memorize it however you're going to remember this. If you take a little joint surface and practice, that's a really good way to remember it. If you don't get yourself a little mini skeleton at home, you can use the skeletons in the lab to practice. So convex on concave, roll and slide in opposite directions. Concave on convex, roll and slide in the same direction. And all of that is to maintain joint congruency. So here's the the picture of the shoulder joint. Roll and slide in opposite direction maintains articular stability. To maintain firm surface contact, the motion has to be accompanied by a slide in the same direction. With spin always occurs about a central longitudinal axis of rotation. And if you have tissue problems like impingement syndrome, that can interfere with your roll or your slide. And that's where we want to do our joint mobilizations to restore the proper arthrokinematic motion. So you can just tuck that little nugget of information away. We're not going to be doing joint mobilizations in this class. You will be doing it in a future class. But play with some bones, whether it's at home or in the lab, and get the idea of what's happening at the joint when the joints are moving in our normal osteokinematic movements that we talked about.